if we can discuss that in detail. So electrical mobility challenges and opportunities, in fact, in Indian scenario is the topic of the discussion today. Apart from this, I'm also going to highlight you some of the projects that I've been handling from DST, MHRD related to electric mobility, right? So as the theme of the FDP clearly states that they are also going to talk about electric mobility control aspect. They are also going to talk about charging and then artificial intelligence techniques. So each domain itself is very large and huge potential of research and finally deployment. But yes, if you see from us, I mean, we ultimately have to narrow down to some of the very key or key and focus points so that you also get an idea. So electric mobility challenges, opportunities in Indian scenario, and we are also going to talk. So we are going to talk about these important points. Apart from these 5 points, I will also be talking about mathematical model that we have developed for a smaller microgrid, and then integration of electrical vehicle and how that electrical vehicle is going to support a microgrid results, and is it really going to help us in regulating electrical power that we have been receiving from the grid, would be the last part of it, right? So basically, when I talk about smart city, before that, as we all are aware, that we have smart grid. So what, though we discussed this in our earlier talk, but yes, a quick recap of it. Introduction to smart grid, if you see. So smart grid, though it's large, but yes, all existing grid system has to be made smarter with the help of ICT, information, communication, and technologies. So in that regard, a lot of initiative in India have already been, have started and is implemented. Gradually, as I was earlier talking about, that distribution company was the main focus, as that was the area where a lot of initiative were required to be taken, because that was needed to be strengthened from the point of the quality power supply, the economical power supply, also from the continuous power supply, right? So these were the things which were the focus areas. So when I talk about smart grid, I'm not talking about generation, I'm not talking about transmission again, I'm only talking about distribution, and then gradually from smart grid to smart city, then all to microgrid, then electrical vehicle penetration. What are the challenges? What is the current technology, and where we are actually heading to will be the flow of the presentation, right? But rather than taking it as a simple presentation and making this talk routine one, I think we should also make the talk smarter. So if you call it as smart talk, in that sense, it has to have a smart grid feature, which is a two-way communication, right? So please let me know if you have any queries. So in microgrid, so smart grid, as I said, distribution is the focus point, and in distribution, what is the current trend is microgrid. So when I talk about microgrid, it's a smaller grid. You have a campus, which is, or a locality, which is having all type of loads and all type of generation, and it also has a point of common coupling. If you see here, it is connected to the grid. So as long as this works fine, as long as you have independent energy generation, right? But if load increases, you have no other option than to ask for additional power from the grid. right? But it has all those features which are present in today's overall electrical scene, which is different generations. You have a storage option, you have linear load, you have non-linear loads, and all of this. So this is microgrid. This is information communication technology. So even if you call it as microgrid, information communication technology together becomes a smart grid. May not be the exact definition, but I have to, because there is no firm and exact definition, though you have IEEE which has given a smart grid definition, but as it has to be tuned to your own requirement, your own need, we always have option of tweaking it, correct? So microgrid or a smaller grid, right, with information communication technology becomes a part of smart grid, right? Smart. So you have smart generation, you have smart transmission, you have smart energy management at distribution level. This is all what we have. So when I talk about information communication technology, it doesn't only need to core electrical engineering. It becomes more interdisciplinary. You have to have computer science engineers, you have to have electronics and communication engineers, and obviously it is electrical engineer, that is for sure required. So then when I talk about smart grid, the next comes to smart city. So smart grid is going to provide power to smart city. So when I say smart city, what I have in my mind, that it should be, though there is again a no firm definition. Is also, if you might have read the Government of India Niti Aayog's report on smart city when they were initially launching, and today also that holds good. But there's no firm definition of smart city. Yes, this city is a smart city. It is all depending on multiple factors and also from geographical location to location. Your need would be probably different. My need as a smart city would be different. So, but ultimate aim is to have good quality life that one citizen can always avail. There are multiple dimensions also of a smart city, where you have to have adequate water supply, you have to have assured electric supply, right? And you have good sanitation. And another one of the factors that was focused by Government of India was on efficient urban mobility and public transport. So I am narrowing down from a smart grid to smart city and then to urban mobility, right? Which is one of the core areas of work in smart cities, right? So now we are going to link how e-mobility can support or can make efficient urban mobility and public transport. So when I say, I mean, how both the things are linked, smart grid and smart cities. So if you think of a smart cities, one of the very first point it was water and electricity. So you have to have ample water and ample electricity. So unless we promote local generation, we cannot make smart cities. Is the reason a lot of initiatives, lot of incentives being given by the Government of India and state governments in various smart cities for generating power locally, right? Locally, power generation could be from different sources, but mainly if you see India and its location, you will find, yes, solar is one of the economical and cheapest option, right? So, but you cannot have solar plant catering to whole of the city. Yes, localized. So when it comes to localized generation, take a community where you have sufficient solar power and it is only catering to the need of the community to certain extent, not 100%, but to certain extent. So, so when I see this community, and then it comes to that community electrical network, which is later termed as community microgrid. So in community microgrid, expectation is that it has its own generation, which is going to support some part of its electrical power requirement. So that is why I said smart city, you will have such a small community microgrids. If you have, I mean, when we read also, and I have also seen in many European countries that you have, I mean, they have created small places where you have all residential, offices, schools, hospital, everything are localized places, right? Maybe far off from the city center, but you have all your needs getting fulfilled at that particular place, right? Your office is also in that building. You don't have to. So such kind of concept, which is also coming up in India, is going to be the solution, and in fact is going to be the solution in terms of infrastructural requirement, right? And that can in fact fulfill the dream of a smart city. So this is what I actually wanted to come to, from a smart grid to smart city, and where you have the government initially, if you remember, they listed 10 such focused area, where one of the focus area in a smart city was urban mobility. In fact, they wanted efficient urban mobility and public transport. So then when I talk about public transport and efficient urban mobility, so efficiency can only be brought in by bringing more technology into it, bringing more transparency to it. So while bringing transparency, obviously you will have to today rely on technology. So it's why electrical vehicle? Why not the conventional vehicle, gasoline-based vehicles that we have today? So as government has committed to when they talk about urban efficient urban mobility and public transport, and why are they pushing to 100% EV by 2030? So the present study that has already been done by various researchers and in fact government bodies, that proposes to analyze and implement battery swapping station to facilitate electrical vehicle penetration, particularly in smart cities. When they said 100% electrical vehicle by 2030, then there has to be a complete mechanism of it. So this is one of the parts of it which can to certain extent push the electrical vehicles sale, right? Other schemes of government of India, where you have green infrastructure for Indian smart cities, green urban mobility scheme, green urban transport scheme. So all these schemes which government has launched are actually part of efficient urban mobility. So since it was efficient, so it has to be so efficiency, one of this in terms of transparency by technological, another in terms of the overall energy which is going into running public transport should also be saved, right? So then you have another option to go for greener power. So as obviously other experts might have also talked about electrical vehicles. So there are many which I can escape. You have we are also aware of different type of electrical vehicles that are being promoted by various bodies, because we know, yes, you have all these vehicles available in gasoline model, but yes, they are gradually being converted into electrical yeah, electric model, right? So basically, why when it comes to efficient urban mobility, why it is electric mobility which is coming in the forefront? Why not IC engine based? So when I quickly compare this, right? So when it is compared, you have greenhouse pollution. You have to have. I think this is one of the reasons, though politically, this is one of the factors which, or if you see ourselves being a developing country, this OPEC, because you have to depend on various countries to buy or import fuel, right? So dependency on other countries is quite high when it comes to fuel. So if we have electric vehicle, obviously we will have utility companies. I mean, we have our own power generation. So this utility company should be is actually the power generated by the conventional sources. But if these companies are also some green companies, like large form of large, say a wind farm, you have large solar power plant. So all of this, if contribute into our grid, probably this dependence will go down, right? So these all are the challenges which we see in the gasoline based vehicular system, right? You have different range. Yes, this is another challenge you have. But recently, when you read yesterday in the newspaper, when you said a company, in an Indian company is coming up with a vehicle which is competing with Tesla. So I think we have a bright future ahead in terms of electric vehicle. So a lot of research, particularly from in Mahindra and in Tata, right? Few new startups also coming in. As I said, Ola Electric also has been working on this for quite a few years, and they have come up with this battery swapping station at least for 3-wheelers, right? So if this gets graduated, probably we will have a uniform model of electric vehicle where we will have battery swapping stations available for all type of vehicles, right? So these last two are still a major challenge which we see, but the other two advantages and these two disadvantages, greenhouse gas and OPEC, is in fact these two challenges are much more than the last two advantages. So we have a lot of work is going on in increasing the mile range and hours to recharge. Now earlier, if you remember, even in your cell phone, we have fast charging, we have contactless charging. Earlier it used to take 3 hours, 4 hours to charge your cell phone. This laptop I am presenting to you, it takes half an hour to charge, right? Earlier, full charging for laptop used to be 3 hours or 4 hours. So this is exactly the same technology is going to be implemented in electrical vehicle, which is going to bring the cost very close to, if you see on the left hand side, very close to the conventional vehicle. It is more easier in terms of maintenance. If you see, you require so many components in mechanical core, pure mechanical vehicle, but if it is pure electrical vehicle, it's only very few components required, right? Different charging station options are there. You have, I mean, this I haven't worked on, but yes, this is just for the information I thought would be fine to discuss at this level. But yes, that day, one of the question was on different charging different type of chargers. So when I talk about different type of chargers, you have various range. So since we do not have, I mean, when I talk about the uniformity in this, yes, uniformity has been brought that to a certain extent that you have at least 4 or 5 variants available. But probably when things progress and some technology gets developed, we will have one uniform or single charging point. So if you see India's motivation for electric mobility, when I say India's motivation for electric mobility, this is really challenging, because as I said, India also has signed that Paris Agreement where they have committed that they are going to reduce pollution. And in fact, we were also appreciated in the recent times when we are found that we are living up to the expectation of the agreement that we signed, right? So in that regard, if you see India's motivation for electric mobility, the single motivation from a larger point of view, if you see, we have to reduce our dependency on countries which are oil rich, right? So that our import reduces. So in the same direction, lot of one is FAME, where fast adoption scheme for electric manufacturer, and you have National Electricity Mobility Mission, which also has campaigned for. But I mean, both of this are contradicting, because what government is saying that we will have by 2030 all of them get replaced by electrical vehicles, though that looks to be very promising and little tough to achieve. But yes, even if we get 30% of them, 30% of the current vehicles to be electrical vehicle, we will probably have, we can probably say, yes, we have achieved. This all is the focus. You have to reduce greenhouse gas emission and improve air quality. This is also one of the part of it, National Smart Grid Mission, because this is focusing mainly on more renewable energy sources, and this is the aim which is expected to be achieved, may get delayed because of these current situation. But yes, this is one of the prime goal of the Ministry of Power, to have renewable generation of 175 gigawatt by 2022. So that also includes, I mean, when I say about 75 gigawatts, not grid connected, we are also talking about distributed generation, like you have generation in the microgrid. It's good if this is only catering to a local community, but or a local institution, but yes, will be part of it. So these are the things which we have been seeing. So I mean, this is just a trend which you can see. I have taken this from one of the resources of IEA, which is clearly indicating that though we do not stand anywhere in the list, but as compared to some of the developed and large countries, right? But yes, push is clearly visible, and it is also quite evident that we have to go in line with this, right? I mean, if you see from the Indian perspective, then we have no other option than to go for electrical vehicle. But yes, though these countries have, but we still do not have very firm. As and when something happens, we come up with policies. But as on date, you don't have any firm policies in electrical vehicle overall operation, keeping a view of 10-15 years. Because another thing that have been probably thought of by these developed countries, that post electrical, I mean, after electrical vehicle or not vehicle, but if battery, so what will happen after its post operational time? Suppose it is post lifetime, so say battery's lifetime is 4 to 5 years. What will happen and how will that be disposed of has not been thought of as of now, but that is going to cause major challenge. Then all of this, if we do not think of all of this greenhouse gas reduction that we are talking about, is in fact will be more, because that is going to be more pollutant in terms of, if you compare with the greenhouse gas emission. So these are the challenges, but opportunity that you see in battery disposing of, it has to be actually there. So something, if one can come out, though that will be a poor material science research, but yes, would be better. I also was talking about the same energy storage and the constraints. Large energy storage can also be thought of, but what will happen? You'll have to get all the batteries replaced. Then again, overall capital cost will increase. So this the earlier slide that I was talking about. This cost is coming closer to it because of the battery cost gradually going down. But today also it's 25 to 30% of the cost of the vehicle that battery has. So any questions so far? Okay. I mean, am I just asking, is there any questions so far? I mean, just 1.5 hours or 2 hours of lecture stretch probably would be too taxing for you, though it's fine from my side, but
yes, sir. I think they'll ask at the end. You just continue with the session.
Okay, fine. So electrical vehicle, so that's all about the current challenges that we see, and probably the opportunities in terms of making fast charging, opportunities in terms of making smart parking lot with solar rooftop. You can also think of mobile charging vehicle. I mean, a truck loaded with 3-4 chargers is parked somewhere at the roadside in the highways, could be an option for one to explore. But yes, we have to have ample number of electrical vehicles. So both will go hand in hand. If you have good charging infrastructure, we can push ourselves to go for electrical vehicle, right? So this is one thing where all those challenges which have been talked about, be it mobility mission that government is talking about, or the private players which are manufacturing electrical vehicle, they are seeing electrical vehicle as a simple load, right? So that what I talked about. Have two different arrows, right? You have grid, grid to home, home to EVSE, electric vehicle supply equipment, and then to electrical vehicle. So today, this blue arrow is what, which is there in most of the policies and most of the planning that is being done for the electric vehicle. But when I said last time that if you assume that all the vehicles, even if you take total number of vehicles, 20% or 25% of the vehicles get converted into electrical vehicle, we will have huge power crisis. I mean, we do not have even power to charge them, right? So we have to develop an alternate mechanism, though could be charging from localized renewable source of energy, or you have to have storage where we can charge vehicle as per our requirement. And another thing is demand side management. If you see the electric vehicle, you have new concept which actually will go parallel to electrical vehicle adoption, is demand side management. So when I talk about demand side management, I am talking about managing your electrical demand. I know, I mean, you are also aware of the electrical load curve, which has sharp dip at the time in the night time, right? So if we think of making pricing dynamic, right, electric pricing dynamic, we can somehow support demand side management. So what is demand side management? Though that is being implemented but only, yes, it is limited to some of the developed countries. So demand side management is another concept which has to be there ultimately to get a push. Though you do not see directly a link, but I tell you, so that demand side management which I am talking about is if I have to charge my vehicle, right? So I will charge if I have dynamic pricing in place when the electrical pricing is minimum. And I said, if you see the curve, there is a dip in the night time, then again rise, and in the afternoon also you have slight dip. So aim is to bring a flat load curve. So flat load curve means your load shifting has to be there, which is the load at the peak hour. If we shift it to the time when you have lesser load on the grid, you can support demand side management. So demand side management would work when we have actually the total what I'm saying is when we have a proper, in fact, the correct term would be a proper coordination, right? When I have dynamic pricing, I'd say, okay, if I charge my car at 5 rupees an hour, 5 rupees per unit, then I would prefer that 5 rupees. And at the peak time, if it is say 12 rupees, I will get charged. So, right? So since in the night time I'm not going to use my vehicle, I'll put it on charging. Let this be charged at a lesser rate. And when it comes to selling electrical power,
and I've parked my vehicle in the commercial place, right, where you have 16 rupees, 18 rupees a unit, I will be able to sell the power. Correct. So unless that demand side management along with dynamic pricing, electrical vehicle, all of this are coming together in our whole smart electrical power network that we will have in time to come. Right. So all of them are coming together. So when I say storage, now I come to the second part. So this is all how storage. So it is not only single electrical vehicle which is going to store, as I said, you have to have an aggregator. Aggregator will have a larger storage and in fact all information of electrical power. So when you have, so this all with respect to the smart city. So in some of the smart cities where urban mobility is taken a major part, or they have started urban mobility concept as pilot in their smart city region, because in hundred smart cities you have different requirement. So wherever this is one of the requirement, they are also pushing or thinking in this direction, right? So all fleet of electrical vehicles directly connected with taking power, supplying power, and you have aggregator. This aggregator will have information about stored power available with it, right? It is able to communicate with independent system operators. It is able to communicate with, in fact, directly distribution grid, right? So all is this communication channel which is well established. So you have two-way power transfer. It has capability of power transferring and then sending it to grid so that it gets utilized somewhere else, right? So this all thing would be fine. But when I say I'm charging my vehicle at 10 rupees, I'm selling electrical power again at 10 rupees, will have no meaning. So this is all dynamic pricing in a smart city, and a smart grid concept is coming up. Correct. So this is one of the parts of it, and other way around is always possible, and it has been working fine. You have grid, it's coming to distribution network, and then it is going to your vehicle. So this has been working fine, but unless we think of other way around, so that grid also gets support. It's not only electrical vehicle that has to be seen as charging. So overall, electrical vehicle energy management and control aspect covers a lot of things. You have to have embedded system engineers to understand and to develop this. You have to have electrical engineer. You have to have computer science, electronics. All of this are ultimately required. And then to place it on in the vehicle according to the appropriate place, we have to have mechanical engineers. I mean, that also decides the amount of power required. So it is ultimately looks vehicle energy management is not only energy engineers who can actually do anything here, but is in fact a mix of and combination of all of this, right? So this is a complex vehicle energy management which we actually started. We took this reference and started working on it. But yes, you have electric motor here, and rest all is fine. Everything is monitored by sensors, and you will have all information on the dashboard, where this is giving you a perfect control and monitoring, in fact, situation at any given time. Whether vehicle is at a standstill mode or it is running. Correct. If you can quickly see, you have all this. You have battery state of charge model. You have proper communication bus. You have total energy demand coming in. How much power has to be sought from the actually sought, and then whether motor will be able to deliver or not. All of this is a complex vehicle energy management function, which would be there inside the vehicle. So basically, when I say electric vehicle, it is not only electric motor that you have connected to a battery and it starts running. You have all this. But yes, the earlier the gasoline based vehicles are more mechanical, this will be more electronic, right? Then this is just a broader picture of it. This is another this is in fact a picture which is inside the vehicle management inside it, and this is overall when you have information processing, or what I talk about when you have to connect yourself to an aggregator about taking power or selling power, or you have to connect directly to distribution system operator, right? This is all EVAC, electric vehicle supply equipment. This is electrical vehicle control center, which is directly coordinating. But all of this are happening through well established communication and sensor networks, right? So for each of this we have a firm protocol, more or less settled, because you have electrical vehicles now on road. But yes, there is always a scope of improvement. So this is the part which is one we have been working on. We have been also working on the overall coordination of this, right? So what is our focus area? And I mean, that can give you idea. This is one of the projects that Department of Science and Technology has funded us on developing an IoT-based energy management system in a community microgrid with electrical vehicle to X feature. I mean, vehicle to grid, you can say, or vehicle to X feature. So this is what we have developed so far. We have developed an energy storage system, wind emulator, and we have solar emulator. So in fact, all of them are interconnected, becomes a microgrid. Having developed a microgrid, overall range is not very large, just 5 kilowatt at the prototype level. We have electrical vehicle and electric charging station. Vehicle is also, I mean, this is an electric vehicle, and you have electric charging station. This is a communication channel, as we were talking about in just the previous slide. So vehicle would be communicating with charging station. Charging station will also be able to communicate to vehicle about the power requirement and in fact the power rate. If I am charging, what is the rate at which I am going to pay? If I have to discharge, what is the rate at which it is going to take power? So this is one of the protocol which is being developed. Another is grid to vehicle and then vehicle to grid. Then this is charging station, which will ultimately be connected to electrical vehicle aggregator, right? Though it looks at the project level, at the pilot level, fine, but actual model is going to work like you have charging station. So I repeat, it is not one vehicle, but it's a fleet of vehicle, multiple vehicles if they are parked at different locations, connected to respective charging station and then to aggregator. aggregator, electrical vehicle aggregator will have all information about will have all information about power requirement. So what is the power demand will ultimately be told by that community microgrid that we have developed. So what is that power demand will ultimately be decided by load. Load is highly random. We all know we cannot comment or you cannot predict exactly what is going to be load next second, next minute, right? So on the same lines, since load is varying, power requirement will be sent to system operator. This system operator that I'm talking about, an independent system operator who is monitoring the whole of the grid, right? So that microgrid system operator will inform EV aggregator whether they are in need of electrical power or not, right? So whatever electrical power is needed by the system operator because it is not getting fulfilled by the renewable or the green sources, and if they find this economical, rather than asking power from the conventional grid or the conventional power plant, they would rather prefer to have a green power getting in. Right? So this vehicle ka power will only be, when you can say green, when it is not being charged from a solar thermal power plant, right? Because if I am charging my vehicle in, say, Pune, and in Pune, if I am not getting, so I said, okay, it's a green power that is coming, no fuel, no nothing, no emission. But somewhere else, coal is being burned to power my vehicle in Pune, right? So, I mean, that doesn't justify. So you have to have green power fueling your car. Then whole purpose gets sorted. Otherwise, there is no purpose somewhere else. Take example of Pilani. I mean, in Rajasthan, you say, okay, now I'm getting electrical vehicle, no pollution, nothing. But somewhere else, Pilani is being powered from one of the plants in Rajasthan, Kota. So, but you are polluting the Kota city's environment because it is burning the coal there to fuel my car or charge my car here. Right? So, is the reason. I mean, all the things, we cannot only think of electrical vehicle alone. We have to go, I mean, it's a comprehensive study that we have to do in order to reach to that level of self-sustained energy country, right? I mean, and in fact, not energy, self-sustained energy country, we are, but with maximum green power input, right? Then all these things would. So when the system operator gives the signal, you have that power fed to the load. So this is one of the projects that we have been working on. And another thing is, I mean, that also is connected to this. Unless we, I mean, today, why do you need? Why do I say yes? I need. I mean, I have wind power plant, I have solar power plant, and I have some energy getting stored in vehicle. So when I say some energy getting stored in vehicle, I have to have good forecasting of all of this. Good forecasting of solar and wind. So when I say these things go all parallelly, these are the things which also we should touch upon. You have to have proper forecasting mechanism for wind. We have to have proper forecasting mechanism so that we can predict at least few hours before that we are going to get this much power from the sun or solar power plant, or this much power from the wind, right? So a lot of forecasting techniques have been developed. We also did using machine learning algorithm and implemented. So I'm going to show you some of those results which are there. So before that, let us come to the mathematical model which is developed here. We have all of this in the model with solar and wind forecasting, correct? Though we use SARIMA and LSTM machine learning algorithms to forecast our renewable power, and then that actually helped us. Yes, we have that much of surplus power. This all, as I said, is all prototype that we are in the process of developing. What we have done so far, I'm only talking about it, correct? But there are a few more things which we have been working on. So we know, yes, this much of power, confirmed power we will have, and then we can schedule. Even emergency loads can be scheduled. Our electrical vehicle charging is also scheduled, and dependency on diesel engine generator is reduced, right? So this is all what we have been working on. So quickly, so when I see this, how is all this going to help me? Why? What will happen? Power saved, but why a grid requires? Because grid has to stabilize in terms of voltage. Grid has to be grid is committed to its customer to give quality power. So grid has to give fixed voltage level. Grid has committed, and I am paying for it. Grid is also committed to deliver fixed frequency, right? A grid today is also committed to include more and more greener power into it, right? So all of this are addressed by this, right? So when I say voltage and green power is one thing, frequencies which is directly linked. I mean, when I say frequency, it means power demand is increasing. So if at that time, if suddenly power can be fed to, obviously frequency will come back to its normal value, right? So this is one of the parts that we have been working on the frequency regulation aspect, right? So energy storage, be it a battery energy storage system or electrical vehicle energy storage. I mean, fleet of electrical vehicle, 1,000 electrical vehicle is equivalent to a larger power plant, a very large power plant, right? So if you can think of 1,000 electrical vehicle part, it's nothing but a large 100 megawatt of power plant just parked in one place, right? So if you have to tap this to enhance the quality of power, there is no harm to it, right? So these are the, I mean, as renewable, so this penetration, so rise in renewable penetration is one. Not only wind and solar we are talking about, because that is also linked with electrical vehicles. So we have taken all three of them into consideration and have seen by increasing the penetration level. So when there is fall in renewable penetration, yes, frequencies fall. But what model we have taken? We are talking about this mathematical model, right? You have load which is highly varying. You have forecasted solar, the forecasted wind. We have electrical vehicle station which is also getting which is also supplying electrical power to ultimately this change in frequency, right?
So this change in frequency has to be, this delta F actually is coming from the forecasted power. So what is that additional frequency support which we are going to get? And then overall change in frequency, this delta F which you see, this delta F ultimately has to be zero. I mean, change in frequency has to be zero, no matter what load you change, what solar you have, what wind you have. I mean, nobody is going to bother about it. What amount of diesel generator you have, all of this will have very less relevance if delta F is large, right? Neither we have to have surplus power because you don't have storage, right? If you have surplus power, you have to have an equivalent amount of storage. So overall power management in a community microgrid on a smart city scenario is going to be like this. You have battery energy storage system, you have fuel cell based energy system. Though it's a simple mathematical model where single order transfer function is taken, but we have a comprehensive model of electrical vehicle. Now it is easily available, one can use it. We also have it in some of our research papers, and the comprehensive mathematical model for PV and wind with deloading option, right? With wind also, just for information, though may not directly be linked, but some of you are interested in pursuing research. Another area of, because the faculty development program, we also have to talk about other relevant research aspects so that one can be made aware of and can, if likes, can pursue. So this deloading aspect that I'm talking about, just give me a minute. I think it is getting discharged. I'll put it on, I forgot to put it on charger. Just a minute. Yeah, sorry for the interruption. So this this is all single order transfer function it's taken, but yes, as I said, we already have a comprehensive electrical vehicle model developed. We have comprehensive wind model developed, which can be used. So another thing which is very relevant, which is very almost equivalent to electrical vehicle supplying electrical power back to grid and making or gaining some incentive. Same thing is true also for wind, right? So this deloading concept is also very similar to that storage, though you do not see any storage in wind, but it has inbuilt if it is operated at a point which is lesser than the operating point. Suppose maximum power that can be supplied by that particular wind farm is X megawatt. If I operate that power plant and take only 0.9 X megawatt from it, so you always have that 10% margin with it. So if there is sudden requirement of power, you can always push yourself, push that wind farm to the limits so that you get additional 10% power. This is used in
some of the European countries for regulating frequency. Electrical vehicle is also seen here in regulating frequency, right? So these are the things which have been which we are working on, right? So some of these results, there are multiple. Since you have a controller here, you have since you have a controller here, you have various techniques to use. We used robust control synthesis. In fact, in robust control synthesis, it is H infinity controller that we used. We also have used PID controller, where gain of Pi and D are optimized. Using Pi and D are optimized using various bio-inspired algorithms, right? And then we had a comprehensive comparison. So we took some objective function with respect to overshoot, undershoot, settling time, and steady state error, and found that whenever there is sudden change in load, frequency gets stabilized, right? So how fast frequency is getting stabilized is what ultimately we want, right? So we have wind emulator, we have solar emulator. So if that is to be researched, what we can do, we took different loads are artificially created and varied by putting different switches on and off, right? So load variation is brought in, and that study was done. So if you see, H infinity controller response was also fine, but yes, but I'm not showing that which one is better or which one is bad. It was just at that instant what the results we got are shown here. That justifies that yes, electrical vehicle along with renewable power sources are together supporting grid in bringing the stability, right? Frequency stability, to be more precise, right? Different control response to variable renewable energy sources penetration, which have also been recorded and are shown here. So ultimately, aim is this is all controller response comparison. And another thing is this, which we did, robust controller response to forecasted and observed power. So if you see, is actual power, but when we did it with forecasted power, you got more precision. So I am not saying that the machine learning algorithm that we used are perfect in terms of bringing the correct information of total wind power and solar power. But what I mean to say is, yes, if we have proper forecasting mechanism, we will have better control, better monitoring, right? In fact, we can have better dependency. Today, though, you cannot connect critical loads to solar plant. Right? You never know. I mean, suddenly you have the cloud on top of it, and power generation reduces, and so the critical loads will always be on either generator supply or on the grid supply, right? Where you have proper control and assurance. So these are the things which have been studied, and we have got substantially
good results. We also did a lot of stability analysis in the community microgrid aspect in the smart city scenario, with vehicle penetration, with wind penetration, and with solar penetration. Right, all the three varied, and we have got these are the results when we have changed only parameters. Right, the main input here was coming from the addition short time active power support, which was actually required to bring stability, frequency stability of the grid, was given mainly from aggregator, electrical vehicle aggregator. Since parameters are varied, therefore you see multiple curves, right? Parameters are varied from 0 to 50%. What parameters I'm talking about? I'm talking about the conventional power system parameters, moment of inertia, time constant of PV, time constant of wind, right? So this is all I have for you. So thank you very much for being so patient in listening to me. I'm not very sure whether you really appreciated this, but yes, you can always write to me, because I understand immediately it is really difficult to uh, ask some questions. I will be very happy if some of you, if I can help some of you in pursuing your research.
Definitely, sir. Yes, participants, do you have any questions? You can drop your question in chat box, or you can unmute and directly you can ask.
There is only two possibilities, sir. Either none of them understood this, storing, or everyone has understood this. Then only you will have.
Sir, actually, topic is quite difficult. Sir, I request you to please mention your email ID in the chat box
Sure,
so that
sure. Yes, yes, yes.
so
Yes,
that
yes.
participants can ask you later also.
Yes, yes, yes. That will be better, I think.
Yes, sir.
So,
Yes. So participants, if you have any question, you can ask now. Or sir has already mentioned his email ID in the chat box so that you can.
yes, yes. I think that would be also a good idea. That if you come across anything of that sort where you actually need my help, and if you think I can be of your help by providing data or by sharing some of the mathematical models with you, then please do not hesitate to write to me.
Yes, sir.
Thank you, everyone.
So, sir, shall we conclude the session? I think participants will write you.
Sure.
Okay. So I would like to take this opportunity on behalf of Department of Electrical Engineering, PS Modern College of Engineering. So thank you, sir, for such a nice presentation and for sparing your valuable time to guide us, all of us, on e-mobility challenges and opportunities in smart cities in India. Thank you, sir.
Thank you so much. Thank you. Thank you very much.
Thank
It
you.
was
And
indeed my pleasure.
yes, sir. Thank you, sir.
Thank you.
Uh,
Thank you, everyone.
yes, and participants, you will get updates on WhatsApp group about and further instructions. Thank you. Thank you for joining. Now, all of you can leave the meeting. Thank you so much.